100 meters, the center of where this engine is firing. Remember, it's 35 meters or so in the air.
Yeah.
Firing. Wow. So you're like looking up at this rocket
That's
engine.
not far if you think about how tall it is.
It is scary close. So you're standing there and like the cavity of your chest is rumbling and you literally cannot hear anything. Like I could be screaming at you from a foot away. You would not be able to hear. It was wild.
That's
I have
cool.
quite a high risk tolerance, and that was one situation where I was like, oh man, I'm too close.
Died.
3, 2, 1, 0.
Here we go, the first episode of Season 2. Welcome back, everybody, to the Engineering Buzzcast, a podcast that proves that you don't need to be a rocket scientist to understand engineering, except maybe for today's episode. My name is Jacob Primus, and I'm joined here today with my good mate and co-host, Daniel Hardy. Now, we have but two words for you today, and that is Season 2. That's right, we're back with the second season of a lineup with not to be missed out-of-this-world engineering guests from all over the globe. And speaking of out-of-this-world guests, we're joined here today by none other than Nicholas Lindsay, the COO of Hypersonix launch systems here in Brisbane, Queensland, Australia. Now, if I asked you to think of a space exploration company, who would you think of from the top of your head? Maybe SpaceX came to mind, founded by a little known man called Elon Musk. Well, funnily enough, Nick used to be the director of spacecraft production at SpaceX, where he was there for 9 years, getting his hands dirty on the Cargo Dragon spacecraft. He'll tell you all about his time at Texas launch sites, sitting in boats in the middle of the ocean waiting for spacecraft to land, and even the time when he was soldering spacecraft components from the boot of his car in the SpaceX car park. But it doesn't stop there. In unison, he thought, you know what, I'll also go join the US Navy Reserves for 9 years as an aerospace engineer on the side, where he got to fly a Black Hawk and even spend time on submarines. Then, when it was time for a bit of a change of scenery, he made his way across the pond to Australia, where he is now, where he was the Chief of Staff for Gilmore Space, the largest sovereign space manufacturer in the entire country, with our own Prime Minister Anthony Albanese having visited just recently. Now, this is where we kick off with his current role at the startup Hypersonix Launch Systems, the leading aerospace company for hypersonic technology here in Australia, where they've just recently been awarded the Engineering Business of the Year. Now, without further ado, strap yourselves in and get ready for an episode that'll take you to infinity and beyond as we explore the cosmos of aerospace engineering with Nick Lindsay. So, Nick, welcome to the Engineering Buzzcast.
Yeah, welcome.
How are you going, Nick?
Yeah, doing great. Thanks for having me.
Good to hear. All right, Nick. So, jumping straight into things, before we delve into this out-of-this-world episode, pun intended, could you give us a quick overview of the work that you do on a weekly basis here at Hypersonix Launch Systems? And better yet, could you define to our listeners what exactly this word or concept of hypersonic actually means?
Yeah, absolutely. So that one's pretty simple. So hypersonic means that the vehicle or item is going faster than Mach 5. So between Mach 1 and Mach 5 is supersonic, and then faster than Mach 5 is hypersonic. So,
and for those listening who don't know what a Mach is 1,234 kilometers an hour, if I'm correct.
Yeah, that's right. That's a pretty straightforward definition. As I mentioned to you guys previously, my background for the past 13 or so years has really been all around spacecraft in the launch service provider industry, but really focused on Dragon and then more recently Aris down at Gilmore Space. So hypersonics is honestly relatively new to me. It's something that I've been aware of and kind of tracking in the background, but really excited to be a part of it. So as COO, my role, especially at a small startup, is pretty diverse. So I wear a lot of different hats. I'm currently responsible for and make up the entire information technology team, human resources team, logistics team, supply chain team. Like, there's a lot going on. Our company is about 23 people. We have a number of open positions right now, so we plan to grow to about 45 or so, provided we can find the right people to bring into the team. But yeah, there's a lot going on, a lot to be done, and everybody at the company is working really hard.
Yeah, it seems like a very buzzing topic at the moment, and it seems like there's going to be a lot of growth and innovation for the years to come.
Yeah, cool. It is, absolutely. Yeah, it's quite timely. A lot of startup success is based on timing, and this company has an amazing background of capability and demonstrated technology, mostly at UQ. And the timing is just perfect for us to present that technology to the world and really put it to good use.
Yeah, because Hypersonix is a relatively new company. What was it born out of, like necessity, I guess, and what market was it born out of?
Yeah, so we're 3 years old, just over 3 years old, and but it's really founded in almost 30 years of research by Michael Smart and his team of PhD students at University of Queensland. So they were really focusing on developing a scramjet engine, and specifically a hydrogen-powered scramjet engine. Cool. And they've done over 6,000 tests of that engine over the years. So the engine has a ton of really great data, and now it's time to go and fly that engine and prove that it really works the way we think it will.
So for those listening, what is a scramjet engine? How would you define a scramjet engine?
Great question. So it's an abbreviation. So scramjet stands for supersonic combustion ramjet engine. And so the basic principle is that engine is moving so quickly that the incoming air compresses and heats up to the point that it can sustain combustion without any moving parts. So no compressors, no igniters. It spontaneously ignites with the hydrogen fuel using the oxygen in the atmosphere, given the pressure and temperature conditions inside of the combustion chamber. So it's super simple in one way. You can look straight through it. It's essentially a hollow tube, but the specific geometry and surface conditions of that engine are really quite critical to getting it to work correctly.
That's super interesting.
Yeah,
that's so cool.
Awesome. Yeah.
It removes a lot of human input because there's no throttle control. I'm assuming you just press the button and you're like, activate, scram, go.
Well, so we're putting it onto UAVs. So our uncrewed aerial vehicles will be totally autonomous. So they'll just do their own thing for the entire mission duration right now. There is conceivably a future where it could be a piloted aircraft. You know, I'm a pilot. I think that would be absolutely awesome to fly a hypersonic aircraft. But the reality is automation is so far advanced now that it almost hurts me to say it, but there's almost no need for pilots anymore. The planes can fly themselves. Dragon, for example, Crew Dragon, Cargo Dragon, totally autonomous, go to the space station and come back to Earth, right? So if you can do that without any human input, you can do quite a bit.
But there's always some little human person down on Earth, though, like
in
watching
the
it all times.
Yeah, just making sure everything's going okay. Yeah, that's very true.
Yeah.
And the astronauts on Crew Dragon do have control over the vehicle in the event that something were to go wrong. They do have abort capability and some other functionality as well as a backup.
So that's what I want to ask as well. So in your opinion, what roles can we really expect to see these hypersonic and scramjet technologies play into the future of space operations? And more importantly, how is this technology currently being utilized? You just mentioned it then, but I guess for the future, what can we expect to see?
Well, so I might expand your question just slightly from talking specifically about space to aerospace more generally. Basically, a hypersonic vehicle is a time machine. Like it flies so fast that you can get to any 2 points on the globe in, let's say, roughly 2.5 or 3 hours. So it shrinks the size of the planet, which is amazing. And when you start thinking about applications where you can be anywhere in the world in a couple of hours, from like life-saving organ transportation to urgent cargo deliveries, or whether those be defense-related or civilian-related, there are so many applications for a time machine that it becomes quite eye-opening. And I'm sure we haven't even thought of the best use cases yet. I think it's one of those technologies that when you present it to the world, other really intelligent, motivated people will say, oh my gosh, we can use this in this new way that we haven't even considered. Right now, the focus in hypersonics has mostly been in the defense landscape. So both offensive and defensive weapons. And a lot of times you'll hear hypersonic vehicles being discussed in the context of a boost glide system. So that means you have a vehicle that's capable of going extremely fast, but it's boosted by a rocket and then let go, and it just glides at that extremely fast
like a slingshot
speed. Yeah, essentially like a
Wow,
slingshot.
that's sick.
So the step change in capability is what we're trying to deliver, and that's in a self-powered by the scramjet engine hypersonic UAV. So now you can have sustained flight, not just a gliding flight, sustained flight at Mach 5 plus. And the really interesting thing is the limit of the speed is not actually from the engine. The engine can go extremely fast. The limit becomes a material properties problem because the vehicle melts at a certain point because it's going so fast, the friction on the surface, right? So now the company, we have had a heavy focus in materials development, and specifically around ceramic matrix composites and some other advanced high temperature materials that will enable us to fly for long durations at Mach 7, Mach 10, Mach 12.
Wow, that's crazy, because that's not what you when you think of hypersonics, you don't usually think of that being the biggest issue.
Yeah, that's
you
right.
think, what about fuel and what about, all this
Like
stuff?
structural, I guess.
Yeah,
Like,
yeah.
if something traveling at the speed of sound, surely it's going to break up,
Yeah,
right?
yeah.
Like,
So structure, this is another thing. So the interesting, and I recently learned this, when you're looking at aerospace structures, traditional aircraft, like a commercial aircraft, the wings are quite flexible. They bend. The loads are usually based on aerodynamic loads. With a hypersonic vehicle, it's going so fast again that it's actually the compressive loads of the atmosphere hitting the vehicle or the driving load case. So you need a robust structure from the perspective of you're essentially trying to be compressed by an extreme amount of pressure on all sides of the vehicle.
wow.
So if you look at our DART UAV, it has a very, very, very short wingspan. It's like 0.7 meters or so.
Is that the one that you have as the main picture of hypersonics
On the
social
website?
media and stuff in the website?
Probably. We have 3 different vehicles. I think
Okay.
we might talk about that in a minute. But
Yep.
the DART UAV is our entry vehicle.
Mhm.
So it's a smaller scale. It's about 3 meters long and 0.7 meters in wingspan. So it's about the size of a surfboard, like a longboard surfboard. So the driving load case, like I said, is really that compressive load. There aren't elongated wings that you have to worry about bending moments or anything like that. So yeah,
I'm
it's
guessing
an
with
interesting new set of
hypersonic
problems.
technologies, you could also look at submarine technologies as well, because I'm guessing it's very similar in terms of pressure and load cases and load bearing and things like that. You could almost use some of the structures and materials from that as well. But then again, you can't really, because there's also the temperature effect and that sort of thing. So
you're definitely not wrong. Like the compressive forces would be quite similar to something at a significant depth. The temperature and then the weight, because remember we are an aerospace vehicle, so we have to try to optimize for weight to the best of
you
our
can't have a flying submarine.
unfortunately not. So it's a really complex problem. And it presents opportunities, I'll say, for a new way of thinking around aerospace engineering. It's definitely not your traditional style.
You mentioned before a couple of the other applications in the aerospace area. What are also the other potential in areas such as military or commercial use? How do you foresee it taking off in those industries? You talked about like the time machine idea and that sort of thing, getting something from one side of the earth to the other side of the earth really quickly. What about military or commercial?
Yeah, so the world's militaries are really just starting to advance hypersonic technology. Some of them are developing offensive weapons that travel at those speeds. I'm not personally aware of a scramjet-powered offensive weapon. I believe most are currently in use are the boost glide style of offensive weapon.
Right.
But when you have essentially a cruise missile going that quickly, there are very few defensive systems that can defeat that weapon. It's just going too fast. And so one of the best ways to defeat those systems, if an enemy were to shoot a hypersonic missile at you, is with another hypersonic vehicle. And there's so much energy based on the velocities that the vehicles are traveling that you actually don't need a warhead. You just need to make contact with the vehicle and
Just knock it out of
over.
its flight path, essentially.
If you hit it at all, it's basically game over. So
That's
Reminds me of
crazy.
in World War II, the V1 bombers or the V2 bombers heading over to England, and the Spitfires would come and just essentially knock them off course. Instead of shooting them or blowing them up, they just knock them off the flight path, which makes the most sense.
yeah, but tracking and intercepting something that's going that speed is
that's
extremely difficult
yeah.
if it's going in a straight line. And then add maneuverability into the equation, and it becomes a whole nother challenge.
That's real advanced.
Yeah. So there are a lot of potential future applications of the technologies, hypersonic tech, in defense military. As a company, Hypersonix has a do no harm policy, so we don't necessarily want to produce offensive weapons. Approach to defensive weapons is still evolving. We want to make sure that it's with the right partners and the right application of that technology. But that's a few steps down the road. Right now, we're really focused on building this DART vehicle as a technology demonstrator. So we want to launch it hopefully very early next year. Our target is Q1. That's going to be challenging. We have a lot of progress to make between now and then.
Wow.
But anyway, so we'll launch this vehicle. It is going to be put on the front of a rocket, so we'll be boosted to hypersonic conditions and then separate from the rocket, and then our engine will take over. Basically, as soon as we start injecting fuel into the engine, it'll self-ignite and propel itself downrange. So
That's sick.
yeah, really exciting. And then we'll take a ton of data and pass that data, obviously, to our internal engineering teams, make sure we understand how the vehicle behaved, validate our models, go through that whole process, see if there are opportunities for improvement. But then with our customer, our partner, will pass them the data that they've asked for as well. And the world is very interested in understanding more of the technicalities around hypersonic flight.
I like it because it's like a shared system. You're using these operations to also share data with others and inspire others and say, hey, this is the potential of this technology. Have a look at this. It's not just for us, sort of thing, which is a great thing as well.
Yeah, that's right. That's the goal. I mean, we are working heavily, closely with U.S. defense organizations as well as Australian defense organizations, and we want to make sure that the information is kept in the right hands and used for the right purposes. So.
Yeah. What are some of the technical challenges and stuff you would face when designing this scramjet engines and stuff like that?
Most of it, like I said, is around the material properties. So parts of the vehicle as well as inside of the engine get extremely hot, so thousands of degrees C. And so we need materials that can withstand that for long durations, or we need really clever cooling systems that allow us to keep the surface of the materials cool and carry the heat away in a different way. So a lot of different ways that you can solve that problem. But I'd say of all the challenges, that's probably the biggest is heat management.
How would the cooling systems work? What are some examples of
so
that?
there are a few different options. You have ablative cooling systems where the surface of whatever it is you're trying to protect actually ablates away or burns away. And as it burns away, it carries the heat with it. And so you want a material that burns away at a slow enough rate that it's not going to disappear throughout the duration of your flight, but fast enough to carry heat away quickly enough. So the space shuttle's heat shield tiles are the perfect example of an ablative material that does that. The alternatives are materials that are capable of withstanding high temperatures, something like niobium, maybe coated in some high temperature.
I've never even heard that.
Sounds so futuristic.
Yeah, so it's in use right now.
Niobium.
SpaceX uses it. Well, a lot of companies use it for rocket engine nozzles. Yeah, the materials are out there. One that will require much more development, and Australia's a little bit behind, honestly, is the ceramic matrix composites. And so these are composite parts that can withstand incredibly high temperatures.
I'm guessing the biggest issue with ceramics at the moment would be the weight component of it as well, because obviously
it's in consideration. I think actually the manufacturing process is quite challenging. So my understanding, and I'm relatively new to this, is you actually have to cure these composite parts in a very high temperature oven, high temperature, high pressure oven, and there just aren't ovens big enough in Australia to produce those parts. So we're actually partnering with a company in Germany to help make some.
How big are we talking here? Like factory size or car park size?
Car park size is probably the right order of magnitude, but it all depends on the size of the component that you're wanting to make.
Yeah, of course.
True. And the number that you're wanting to make at that time as well, I assume.
That's it, yeah. So, we're still very early days. We're only producing a few technology demonstration vehicles, but we have big plans to scale up into manufacturing. We want to be able to produce these vehicles at a pretty good rate depending on market demand. And, we've mentioned other vehicles that we're producing in the future. So we have DART, which is the 3 meter long, relatively small, simple, you could call it like a minimum viable product. So how do we just demonstrate that we can do this? Because it's quite challenging just to get to hypersonic speeds. And then the evolution of our product line is towards a vehicle called VISR, VISR, which stands for Velos Intelligence, Surveillance, and Reconnaissance. So
what's Velos?
I don't know, to be honest with you. That was a name picked by the team.
Someone's last name on the team.
Yeah.
Bit like naming a street.
I don't know. I wonder if it relates back to like Latin for velocity or something like that.
Yeah, it wouldn't surprise me actually.
I'd have to look.
Yeah.
But anyway, so we're developing VISR to be a high-speed reconnaissance aircraft, essentially.
Cool.
You can imagine a lot of really cool applications of that. And then we have a follow-on vehicle called Velos Orbiter. And Velos Orbiter is a small satellite launch vehicle. But the Orbiter is... it's only one stage of a 3-stage vehicle. So you essentially have a rocket booster as your first stage.
Yep.
And then you have a hypersonic aircraft on the front of that rocket booster.
Right.
And then inside or part of the hypersonic aircraft is another rocket. So you have a 3-stage system. The booster gets you to high altitude and high velocity, Mach 5-ish. You can essentially fly your next rocket to any point conceivably on the globe where you'd like to launch from. So it opens up a lot of different opportunities to launch to almost any inclination from almost anywhere on the planet, which is really
That's
kind of cool.
That's
'Cause
so
I'm guessing,
crazy to say.
like that's the biggest problem, is just getting it up there and getting through the atmosphere and getting through all of that thick, dense atmosphere, and then getting up there. Once you're finally up there, you can activate it and get to wherever you want.
Yeah,
sort of
wow.
thing.
That's it, yeah. And so
That's awesome.
it opens up a lot of really interesting use cases for putting satellites into orbit. It takes a lot of mass, like a very large vehicle, to put a relatively small amount of mass into orbit. So generally, a rocket with about a 1% payload mass fraction is doing really well. So if the vehicle weighs 100 tons or whatever it's going to weigh, if you can put a ton into orbit, you're doing great. Our vehicle, because we're optimizing more for maneuverability and capability, is not necessarily going to have the greatest mass fraction when you compare it to other orbital launch vehicles, but it presents new and interesting ways to deploy satellites, probably smaller satellites like CubeSats or
If you're going from point A to point B, why is maneuverability such an issue there?
It's an interesting question. So it comes back to defense applications and the potential for an adversary to want to take out your satellite launch. So if you have a predictable trajectory that's roughly a parabolic trajectory heading towards orbit, you can potentially intercept that. But
Predict it.
Yeah,
Yes.
exactly.
Yep.
And whereas if you're flying an aircraft, a very, very fast aircraft, you have the ability to maneuver if you need to and avoid any type of attempted intercept.
Well, what do you see as some of the biggest opportunities for progress in the space industry in the next, 10 years? And how are engineers working to take advantage of these?
Yeah, so with regards to the space industry, so this is a little probably outside of the hypersonics conversation, but the space industry, the next game changer is rapid and complete reusability. And so SpaceX is making incredible strides in that direction. Obviously, Falcon 9 first stage boosters are reusable, but the second stage booster is not. That's thrown away on each mission. Basically, it was too big of a mass penalty to try to incorporate reusability equipment, whether that's a heat shield or a parachute or whatever. There's a lot of really interesting thoughts on how you could accomplish that, but you would add so much mass to that second stage that it wasn't worth the effort. But now with Starship, the entire vehicle, booster, and the Starship itself are completely reusable.
That's so cool.
So in theory, they could land and refuel and launch again same day.
That is so cool.
It's like shooting a bullet and then going up, retrieving the bullet and putting it back in the
Yeah,
cartridge.
fire it again. Exactly.
That's so cool.
So, Elon talked a lot about getting to airline-like operations, and that means rapid flights. Like last year, SpaceX did something like 60 launches, or it might have been over 60 launches.
When you think about the magnitude of a space launch,
yeah, it's crazy.
60 times.
It's absolutely crazy.
Man.
But
once a week, bro.
Better than, right? And most people don't even realize that.
That's
and part of that is because they've made it routine. And I remember very early on working at SpaceX, and I can't remember if it was Elon or one of the other senior leaders, but they basically said, we know we're successful when people stop paying attention to rocket launches. And I was like, that's crazy. Like, why would anybody ever not care about a rocket launch? It's so cool. Yeah.
Let's go to next week's one.
Yeah, exactly. Here we are, where it happens all the time, and I don't even necessarily know that they're happening, and I'm like in the industry and paying attention because they're just happening like regular clockwork now. So, if you compare that to people, let's say in the early 1900s, who were excited to go watch an airplane fly for the first time because it's like new and exciting, and then now there's probably 10 over our head and we don't even think
Or even
about it,
the Apollo missions, for example.
Sure.
Everyone crowded around their TV being like, whoa. Like, of course, that's a big step at that time, but but now it's still
same concept. People lose
same
interest
concept.
when something becomes routine, and that is in a weird way ultimate success for a company like SpaceX.
Yeah.
So I think Starship flights will be extremely exciting to watch. The amount of payload from a mass standpoint is just mind-boggling. I'm sure there are scientists at NASA who are drooling over the capability that provides from new instruments and telescopes, and who knows. And there's conceptually you could use one Starship as a fueling vehicle, refuel another Starship, and go even further into the solar system. So there's just going to be
The world's your oyster, really.
Yeah,
with the
imagination
opportunities.
is the
solar
limit.
system is your oyster.
Oh, cool.
I like that one. The solar system is your oyster.
Yeah. It just changes. It's game changing. It's a step change. And again, it's one of those transformational technologies that I don't think mankind has really understood how to take full advantage of it just yet.
It's like the AI revolution as well.
Yeah, that's a whole nother crazy.
Yeah.
Crazy
Well, I imagine traveling at the speed of sound, traveling at Mach 5, there's got to be a lot of safety considerations. So touching on safety here, as old mate Uncle Ben famously said in Spider-Man, with great power comes great responsibility. So how does this apply to hypersonic flight operations, and what measures are taken to ensure both effectiveness and also safety during the testing and operational phases?
Yeah, it's a good question. That at a very high level, every single piece of hardware that goes into our vehicle will go through a formal systems engineering process by which we declare that it's qualified. So capital Q qualified. So we prove that it will operate. The design is suitable to operate in all known flight conditions, plus some margin around that. And the margin is one of the variables that we consider for each and every mission. So our risk tolerance changes mission by mission. And just to use an extreme example, the first one we build, just technology demonstrator, we want to make it happen. We won't have people on board. The launch pad will be cleared when it launches, right? The risk to humans is very, very low. Yeah. Whereas fast forward 10 years in the future, when we're flying hyperliners, right? Hypersonic airliners, like we're going to have, my kids and grandkids maybe on those vehicles, and we will absolutely ensure that they are as safe as practically can be. And
How cool is that?
It's a phased approach. So right now we have a very high risk tolerance intentionally. It's a conscious decision to accept risk for the sake of moving forward very quickly. And then as we move forward very quickly, we're going to learn a lot. We're going to understand the true limits of the hardware. That'll force us to create better and better systems that ultimately are more safe. So kind of a long answer to your question, but the safety and risk posture may vary system by system as well for us right now. So we are using hydrogen as our fuel. Hydrogen's not the friendliest element to work with, as long as you pay it a healthy respect and understand how to handle it and keep appropriate safety systems in place, and that's in the form of like physical systems as well as safety processes and procedures. Then the risk of somebody getting hurt or some hardware being damaged is quite low.
And that's the thing, everyone thinks of hydrogen straight away. They go, Hindenburg. Come on, Hindenburg. What happened there? The hydrogen.
No, that was really unfortunate. There are lessons to be learned. But hydrogen is actually making a bit of a comeback. So it's already being put forward as a commercial aviation fuel, which there's some energy density challenges associated with that. Basically, you have to pack a lot of molecules into a vehicle to get equivalent range that you would get with another hydrocarbon like jet fuel.
Right.
But we will overcome those challenges with time. And then it's also being used in automotive industry. So you can buy off-the-shelf hydrogen tanks for cars right now. So those are Department of Transportation rated, so extremely safe with very large margins. So we're actually just buying those off-the-shelf tanks, using them for our own vehicle.
That's awesome.
They're probably a little bit heavier than they need to be, but to prove the technology quickly, we're willing to make that compromise.
Yeah, and I mean, if it's going to be utilized in things like cars and trucks and vehicles, then obviously, it's going to be safe for space flight as well.
Yeah.
So,
and for our team to work on, right? Like we take safety very seriously.
Yeah, for sure.
As seen in recent news, Hypersonix is working on developing not one, not two, but 3 composite reusable hypersonic platforms. That sounds like a massive undertaking. Can you sort of walk us through the process of designing and building these platforms, and how your team's managing this insanely cool project?
Sure. So minor detail there, mentioning 3 composite reusable hypersonic platforms. They're not completely composite. We like to take a very practical approach to manufacturing. So where it makes sense to use a composite material for a lot of different reasons, cost of the material, features that can only be incorporated into a composite part, mass is obviously a huge consideration. But anyway, so we'll use composite where appropriate. We're also pursuing additive manufacturing techniques, so 3D printing of metals, and we'll use those metals where appropriate.
That's cool.
And then we're not against more traditional forms of manufacturing, like sheet metal, for example. Like it works great. You can achieve incredible tolerances. We just have to be considerate of the application. So anyway, so we'll take, like I said, a very practical approach to manufacturing across the board. The three vehicles are the three vehicles I mentioned earlier. So DART, Visor, and then Delta Velos Orbiter. We're starting work on all three in parallel, but at different phases. So right now, DART is progressing quite far along. We're going through a formal systems engineering process, working through system requirements review, preliminary design review, critical design review, and on towards flight. In parallel, we'll be slowly growing the team, taking lessons learned and adapting the design, basically scaling up the design from a 3-meter vehicle that's not necessarily reusable from the get-go, and incorporating those lessons learned into Visor, and now making a much larger vehicle, around 9 meters in length, and incorporating an undercarriage landing gear, as well as some other features that our customers are very interested in. We're not trying to tackle all three simultaneously necessarily, but making good progress on DART
if you had to.
and then rolling those lessons learned into the next one. But we are growing our team at the same time to make sure that we can scale to do all three at the same time if we need to. We're also making careful decisions about when we bring team members on board for the various phases of the life cycle of the vehicle. Right now we're very much in the design phase, and we're quickly going to move into some manufacturing. And so we'll want to bring in some technicians with experience in aircraft manufacturing to make sure that we're doing the best job that we can. That their knowledge and experience, hands-on knowledge and experience, which is so valuable, is rolled back into the design, so we don't design a particular piece of hardware that, let's say it has a fastener on it and you can't even get a wrench in to tighten up the fastener. Right? Like I've seen it so many times, unfortunately.
The Land Rovers.
But if you have the technician in there looking at the CAD with you, he's like, how am I supposed to fit my hand in there? Great point. Let's make a design adjustment early. It's a dynamic landscape, but we're taking, I think, a really practical but quite aggressive approach to solving hypersonic.
I think it's also a really strategic technique to offset the development as well of all three, so that when you're working on the first one, the challenges and the lessons learned from that first one, you can then apply to the second one. And
even the
so
processes, right? The team is incredibly smart and capable, and their experience is amazing, but not all of them have been through a systems engineering process before. So just learning how to how do we host a really good requirements review? I don't want to have a review for the sake of having a review. Everybody needs to either be adding value or walking away with value from that potentially all-day meeting, which nobody likes an all-day meeting. But so we have to make sure it's really useful. And so going through it for the first time on a smaller vehicle gives the opportunity to learn how to do those things well. And then when we roll that into the Visor aircraft, now we'll have a team of seasoned might be a stretch, but experienced engineers who already know what they're doing, and we won't have to ask a lot of the fundamental questions, and our goal will be just to continue to accelerate.
And I imagine on a smaller platform too, it helps out a lot first starting off small and then to get to big later on, because then you can learn those challenges and those things later on, and then essentially after that you've just got to scale it up, right?
Sounds simple when you put it that way. Look, there will definitely be challenges, but that is overall the approach. Like, let's start with something relatively easy. When you're talking about building hypersonic UAVs, let's start at the easy end, but do that really quickly, and that way we learn fast, fail forward quickly, and move on to more capable vehicles as soon as possible.
So these three platforms, are they being built here in Australia, or are there some components being designed overseas or built overseas?
It's a combination right now. So we do have to be really conscious of export regulations in Australia. And then, as I mentioned earlier, we are partnering with both U.S. and Australian defense organizations. And there's a lot of details around limitations of where we can get our hardware from, where we can export our hardware to, that we need to be carefully considering each step of the way. Shorter answer to your question is we want to manufacture in Australia. We are taking steps to make that happen right now. A number of states are actually working with us to try to attract us to their locations to stand up a manufacturing facility. Some of the work that I did at Gilmore Space was going from a clean sheet of paper essentially to a manufacturing capability down in Helensvale. And so we grew the team over the course of 3 years from about 30 to over 180. Wow. And it was only growing when I left the company last December.
That's bonkers. It just shows how much room of innovation there is.
There's
to
so
go.
much,
Like,
exactly. And
this is it.
And they are now running out of space. Every time we acquired a new property, we filled it up before we knew what happened, and had to go out and search for more property. So the opportunities are really incredible to bring some advanced manufacturing capability back to Australia, because that was honestly, like, as an American coming to the country, that was one thing that I underestimated, was how little manufacturing capability is left here.
Wow.
I know, like, a long time ago, Australia used to be quite powerful, had automotive manufacturing and a lot of other capabilities. But
even aircraft production was quite...
Yeah, but it's all, it's gone away, and we're starting to see it come back, which is excellent. And there are some incentive programs to enable that, and hopefully Hypersonics will benefit from some of those incentives.
Yeah, so on challenges, I guess, you talked a little bit about the technical challenges, talked about reusability. So I want to combine the two, and I want to ask you, so how will hypersonic technology specifically attempt to meet sustainability objectives? Recognizing that these reusable scramjet engines are the current mainstay of hypersonic engines, could you shine a light on anything further sustainability, such as you just mentioned green hydrogen fuel as well? So could you touch on that just a little bit more?
Yeah, like I don't want to necessarily overstate our emphasis on sustainable activities. We definitely want to create sustainable systems, no doubt about it. But hydrogen is an amazing fuel from its energy capabilities and simplicity. So there are a lot of, I think that's where the big wins are, is at the intersection of something that is good for the planet, good for the industry, and provides great performance, which is always very hard to find. But for an hypersonic aircraft, performance kind of has to be our first consideration. Yep. And then after that, we can think about how do we take the correct performing solution and adapt that to be more sustainable. So, our initial vehicle, like I mentioned, is a vehicle that will probably just fly, transmit data, and then potentially not be able to be recovered because it doesn't have landing gear. We can control it, we can soft land it, but it's going so quick that it and
have fun catching that.
Yeah, we have to fly it downrange, most likely over the ocean, which means it's going to be very hard to recover. So the long-term plans are build a vehicle that has more traditional landing gear, execute our mission, and then fly it back to base, land it on a normal runway. So we'll take steps towards full and rapid reusability, similar to what we talked about with rockets. I think our problem, honestly, with a hypersonic UAV is a lot simpler than it is for a rocket. But like I mentioned, we do have to be boosted to the altitude and speed conditions to ensure that our vehicle will work, that our engines can even ignite.
Will the booster use hydrogen?
No, probably not. Well, not necessarily, I suppose.
Well, not yet.
It could, yeah. And we're actually not going to be the designers of those boosters.
Yeah.
So we're talking to a few launch service providers to find the right match of their capability from a performance perspective. And then we can work with them on sustainability solutions down the road. I mean, ultimately, the long-term goal would be to create an aircraft that could take off from a normal runway, accelerate to hypersonic speeds, fly its flight, and then land on a normal runway, right? So complete reusability. Right now, there is, I've heard it called the Valley of Death, but there's a gap between about Mach 3 and Mach 5 where there isn't suitable engine solution to drive the vehicle between those speeds. So, you can take off from a runway with a turbofan engine like you have on, any commercial jet. You can then accelerate and use a ramjet engine to get you to about Mach 3 or so. And then your scramjet engine or supersonic combustion ramjet really doesn't pick up till about Mach 5. So there's a gap there that we need to bridge. And right now, the easiest way to bridge that gap is with a rocket.
Do you think that there's going to be anything in the future that might be able to?
Absolutely. I mean, it will happen. It's a matter of time. Like, when will it happen? There's some companies doing some really interesting things around combination of engines. So it may switch from a more traditional turbofan to a ramjet engine at one point in the life cycle. There's a company in the U.S. called Hermeus that's doing that. A colleague of mine from SpaceX actually is the COO at that company, which is always fun. Cool. Yeah, so it's a good, friendly competition there with those guys. But they're doing some amazing stuff, and who knows, maybe there's an opportunity to partner as well in the future.
Right. And it's cool because a lot of all these startups in hypersonics are probably like, they're all in this together. Like they're all trying to do the same thing.
We are.
So you can sort of like even bounce ideas off each other every now and then.
I'd love for it to be a really open conversation. I'm an engineer first, and then kind of evolved into understanding business. But it is a commercial enterprise, right? Like we do need to protect our intellectual property to the best of our capability, and we want to be the first to market with the solution that the market is looking for. Tough to balance that with my internal motivation as an engineer. Just like, hey, let's just smash our heads together and like make this work, right?
Yeah,
like, we
yeah.
can do
Let's
the
all
work, bunch of
collaborate,
smart
guys.
people. Exactly. Yeah. So that is a bit of a challenge, but I hope there will be opportunities for us to collaborate and then benefit commercially as well.
Especially across defense technologies as well. It makes it so tricky, hey?
It does make it tricky. Yeah, very true. But there's commercial sensitivities there. Our investors want us to be the first one to succeed here, understandably. I've personally invested in Hypersonics. I believe in the technology. I believe in the team. But we do need to be open, I think, to the idea of working with others as well.
Yeah.
And now's the right time to be collaborative. I mean, we've got all these amazing platforms. You can just call up anyone on the side of the earth and just like, hey, let's just bust this thing out over a whole day and have a long day meeting over Zoom. And it's the best time to do it. You can share files whenever you want. It's the easiest. Right now, it's the perfect atmosphere, I think.
It is the technology is there to make sharing pretty easy. From a communication standpoint, has shrunk the world to essentially zero, which is great. And we are actively partnering with universities as well as government agencies. But I do think it would be pretty interesting to see some more advanced players come together and really deliver something amazing.
Yeah, let's do this thing. It's come together. Come on, let's see what we can make out of it.
That's right. And if you think about it from a business perspective, the incentive to do that, the financial incentive to do that, because there's the altruistic incentive to work together to deliver value back to the world. But the financial incentive needs to be there as well.
Yeah, so definitely.
I think we'll be looking to defense organizations to say, hey, you guys can do part A really well, you guys can do part B really well, we'll pay you both handsomely to work together and put them together to develop something that's greater than the sum of the two parts.
Nothing really gets anywhere without that business incentive behind it.
And that's a realization coming out of university as well. Like, it's all fine and good to have the world's greatest widget, but if you don't have a sales team backing you up to go out and present that to the world and say, here's why you need this greatest widget, then it's just going to die in a dark closet somewhere. So, it all needs to come together.
Yeah. So, Nick, if you will, a little bit of myth busting. So what are some of the biggest misconceptions about hypersonic and scramjet technologies specifically? How does Hypersonics work to educate the public and promote a more accurate understanding of these technologies? You mentioned working with universities and working with the youth. What are some of the misconceptions that people should know about this industry?
It's a good question. I think what we talked about earlier with regards to temperature being one of the limiting design factors right now. They're literally just materials do not exist in the known opportunity of material. On Earth, materials do not exist that will survive the heat of some of the conditions that a hypersonic vehicle will see at speeds in excess of, let's say, Mach 10. So until we invent kryptonite or some other amazing material, that is going to be a big challenge. And I didn't necessarily appreciate that aspect of the challenge. I thought, developing the engine might be the most challenging piece, and I don't want to, understate how difficult that is. And that's a project in and of itself. But Michael Smart, our CTO, has done an amazing job to deliver an engine that works. Now we're moving on to the next challenges. And I guess coming into the industry, that was one of my misconceptions. But to be honest, it's a bit hard for me to know what public misconceptions exist, because I don't think there's a lot of public knowledge about hypersonics in general. Which maybe that's where we need to put some work in, is just raising awareness.
That's probably a good thing that people probably don't know about hypersonics that much at the moment, because there's no preconceptions. So you can go out there with a good image and be like, hey,
slate.
Here's how they work. Yep, this is how you're going to get to New York City in 2.5 hours.
A lot of people will probably just hear hypersonic and supersonic and think they're the same thing.
Yeah, absolutely. And I understand that.
Yeah.
Actually, I did think of one thing. So when I've talked about the concept of a hyperliner before, an airliner that's going Mach 5 plus, let's say Mach 7. A lot of people automatically think, well, how is the human body going to react to going that fast?
That's a good,
right? But if you think about it, the human body doesn't react to velocity, it reacts to acceleration. So if you and I are sitting here in 1G, that's quite comfortable. We could equally be flying Mach 20 but not accelerating in any direction, it would feel exactly like this. Right?
Yeah.
So
Relative.
the speed does not matter at all, but the acceleration does. So when you're in an aircraft and you're rolling down the runway, pilot just went full throttle, you're accelerating at some rate. That's what your body's feeling, pushing you back against the seat. It's not the speed, because once you're up and cruising at 400 knots, whatever, then you feel quite comfortable and you can take a nap. Doesn't bother you.
Just take a nap at Mach 5,
Yeah.
So does that mean
100%.
that the biggest challenge for commercial use is going to be how we accelerate, how long it will take to get to that point, and how we can keep humans safe in that?
Yeah, that's a great connection. I think it's going to be a real stretch, but who knows? I don't want to be too close-minded, but I think it will be a stretch to convince the general public that they want to climb into a hypersonic airliner that's strapped to the front of
If they don't know what it is.
Well, a rocket booster, right?
Oh yeah, true.
So right, that's the key. So if
we're going to put you in a metal tube, strap a rocket booster to you, and fly you to Mach 5. You good with that?
Who knows, right? Like we already are seeing space tourism take off. That's the same.
Just like getting a rocket,
Yeah. Well, it literally would be.
I think it's going to be a generational thing too. There's going to be a generation brought up watching SpaceX and watching these space launches happen weekly, like you just mentioned. Oh,
more than weekly.
Yeah, more than weekly.
They wanted to do 100 launches this year, 2023, 100. So twice a week.
It's so insane, isn't it?
I think they're on track so far. Honestly,
that's so cool.
Wow, that's pretty good.
But anyway, so we need to solve the acceleration problem. That's long story short. And so it comes back to how do you bridge the gap between low speed acceleration and that high speed flight? So we need engine technology that can take you through the current acceleration rate that you experience in a normal commercial airliner flight and just make the top end of that acceleration a much, much higher velocity.
And you got to basically convince the humans as well that that's okay. I mean, like people are freaking out about turbulence in aircraft, let alone traveling up to speeds of Mach 5. So I think it'll be a slow approach, but I think once we get there, I think generally the approval will be a yes. And I think with humans as well, they usually give the green stamp of approval if it impacts them in a positive way.
Yeah, exactly.
So like you just pitched it before, you could fly to New York in a couple of minutes. Like people will be like, oh yeah, that's great.
Sydney to New York is 2.5 hours roughly.
The way you talk about humans is like an alien.
It's true. Look, we are humans are complex creatures, right? At all of the companies I've worked for, we always say that engineering is the easy part. Like working with people is the hard part. So
for engineers,
designing things for these aliens.
For engineers, yeah. So we definitely need to keep people at the forefront, both our employees as well as our customers, as well as our potential future hyperliner travelers.
Hopefully, fingers crossed. Seems like a good time to be an engineer anyway. At least in the aerospace industry.
Honestly, it's super exciting, and that I've spoken at a number of universities in the area, and one of the things I found surprising, and I think it's a cultural difference, honestly, between the U.S. and Australia. In Australia, I think the country as a whole is a bit more risk averse, and so students growing up, whether it's in high school, I think you guys call it college, or university, they're not necessarily encouraged to go out and pursue their dreams. Like whereas in the U.S., everybody's like, you can be whatever you want when you grow up. Just dream it. You can be it. There was a time where I wanted to be a ladybug, which I don't think that is now possible. But
who knows?
Who knows, right? Exactly.
Biotech.
Yeah. It's only not possible if I have a bad attitude about it.
Just paint yourself red and put a bunch of black dots and run out the street.
That's it.
I'm sure people won't look at you any different.
But I found coming to Australia that you talk to university students, and because I'd be there talking about rockets and aerospace and how exciting this is, but the feedback I would get is my mom, my uncle, my teacher, my guidance counselor has told me, don't pursue aerospace engineering. There's no real jobs in it. Go and be a civil engineer or do something else. And it's like a little bit heartbreaking to hear people's dreams squashed like that, especially when right now there are a ton of opportunities in Australia, whether it's for one of the big primes like Boeing or Northrop Grumman, whatever. They've got some really cool projects going on, or a defense organization like DSTG. They're doing some really cool stuff. I'm obviously biased. I think everybody should want to work for Hypersonic. We're like doing amazing things at breakneck pace with little to no bureaucracy, which is excellent. Gilmore Space is still doing amazing stuff as well. So it's a great time if you're interested in
it's happening right now.
It really is.
It's the best time. Jump on in.
That's it. There are open jobs at all of the companies I just listed right now.
It is such a challenge to flush people into this industry though. It's like open the door and say, hey, look, this is what's going on.
Well, the other thing that it's hard to realize, and maybe now that I'm like just a little bit older, I'm 38. But now that I'm a little older and can look back, the thing that you don't really understand as a college kid is you're quite robust to failures. So as an example, let's say you take that leap of faith, you study aerospace engineering in spite of the fact that the industry may not be fully mature in Australia. You jump into a startup company, like Hypersonix or Gilmore Space, or there are a number of others that are starting to get going. And let's say it doesn't work out for whatever reason, the funding doesn't come through, or something happens where the company doesn't succeed. But you've spent a year, 2 years, 3 years at a startup learning at a pace that is twice that you'll get at a big aerospace company just by the nature of the pace of execution. And so you now re-enter the job market, and sure, you got to go find another job that isn't fun, but it's not that bad. And your resume is now amazing.
Experience.
Yeah.
Right.
Like this person spent 3 years learning how to build hypersonic aircraft at a startup company.
Yeah.
They probably wore multiple hats. They weren't just like working on one little widget. I had somebody, I won't call the company out by name, but I had somebody I interviewed recently who told me that they spent months working on one little nut that goes onto a bolt. And then the funniest thing was, when it came to the end of the story, basically they couldn't use the nut that he proposed. They had to go back to the original nut that the aircraft had been using for years. And that was his whole experience of this company. And I was like,
designing a nut that no one uses.
That no one uses. I was like, how is this even possible? So I guess what I'm trying to say is, when you're young, you have relatively few responsibilities. You probably don't have a family yet. You probably don't have a big mortgage yet, right? You're relatively portable. It's not a big deal to move to a different city or even a different country to try something new. So take the risk. Go out, give it a shot. What do you have to lose, really?
Yeah.
I think, honestly, the answer is nothing. You actually stand to gain quite a bit of experience and knowledge and understanding of if the startup environment is the right one for you. And maybe it's not, because it's different.
It is different. And I think it's a thing that not everyone always considers. I think a lot of people see career security in other larger companies, and they think, oh, okay, I can just fit in there. They've got a HR department, and they've got this, and they've got that. They can take care of me. Like, a startup's I think people see it as a risky move almost.
I told you, I am the HR department. We're the HR department. I'm sitting right here. No, and that, those points are valid, but I think expanding your horizons and pushing your own personal limits a little bit is healthy, and put yourself in a situation where you may not be the most comfortable, but you may thrive more than you expect. And yes, there are going to be, let's say large oil and gas companies around Australia that will hire you and keep you employed for 30 years or however long you want. But at least for me, I wanted more excitement out of my career. I wanted to have a real impact on the projects that I worked on. So that was actually the reason why I ended up leaving active duty U.S. Navy to go and work for SpaceX.
Wow. Now, for those listening at home, what we'll do is we'll shuffle on over to episode 2, where we'll cover Nick's story. And I mean it when I say this, you really don't want to miss out on this jam-packed episode. It is quite literally out of this world. We talk about Nick's time at SpaceX, Gilmore Space, his time in the US Navy, and we dabble in some insane stories about Falcon 9 rocket launches, Top Gun, and what it's like to work for a company owned by the man himself, Mr. Elon Musk. So, what are you waiting for? Head on over, hit that play button, and we'll see you over in episode 2 very shortly. Also, just a quick little reminder, if you're enjoying what you're listening to, and if you are, please give us an honest rating over on your preferred podcast platform. It really does help us out. Okay, enough from me. See you soon.
You've been listening to the Engineering Buzzcast with Jacob and Dan.
Check out their sick new website at www.theengineeringbuzzcast.com.